In this question, a 5% solution by mass of cane sugar in water has freezing point of 271 Kelvin. Calculate the freezing point of 5% glucose in water if the freezing point of pure water is 273.15 Kelvin. So here it is given that the temperature of a pure form of water is 273.15 Kelvin. Now when we are mixing cane syrup in the water, then the freezing point will become 271 Kelvin. So this we can write it as TF, it's equal to 271 Kelvin. So these temperatures are based on when we are using a cane sugar. Now cane sugar we are removing and we are substituting another case in which we are placing a glucose. Means you can understand this in a simple way. What happened? We are taking a pure water. Here we place the water. In this water, if we consider this is water here, in this water we are adding cane sugar, and in the second case we are adding glucose. So when we are adding cane sugar and glucose, we will see the depression in the freezing point. Here when we are using a cane sugar, that time depression in the freezing point, this is 271 Kelvin. This is the new temperature freezing point. And here glucose we don't know. So we have to find out how much is the new freezing point when we are using a glucose. This is unknown. So to solve this question, we have to use the depression in the freezing point formula. And based on that, we can find the freezing point of the glucose. So as you see here, the cane is actually the 5% of the total solution. Similarly, the glucose is also 5% of the total solution. So what we can do, we can split this question into two forms. In the first form, we are taking a case 1. Case 1 means we are dissolving cane sugar. And in the second case, we are taking a glucose. So based on that, we already know that T0F for the water is 273.15 Kelvin. It's same for both the cases. And here TF is equal to 271 Kelvin, that we have to find it here. And then we can assume the mass of the solution as 100 gram. Let the mass of solution is equal to 100 gram. So the mass of cane sugar is equal to 5 gram because it is a 5% of total solution. Similarly, here the mass of glucose is also the same as 5% of 100 gram. It's equal to 5 gram. Now we have the mass of glucose and mass of cane sugar. So if we apply our depression of the freezing point formula, we can write it as delta TF is equal to KF into molality. So here this is KF, it is the freezing point constant, and only depends upon solvent. It has no relation with the solute. Means whether we are using the glucose or the cane sugar, in both the cases this KF remains the same because it depends upon the water. So now if we relate these two formulas based on our two different cases, so we can say that for cane sugar, delta TF is actually change in the freezing point. It's equal to T0F minus TF. So 273.15 minus 271 Kelvin. It's equal to 2.15 Kelvin. So we got the difference in the temperature. So we can use the formula 2.15K is equal to Kf into molality. So first we find the molality of the cane sugar. So molality formula is equal to mole of solute divided by mass of solvent in kg. So mole of solute is equal to given mass by molar mass. So given mass we have 5 gram and molar mass it's equal to 346 gram per mole divided by mass of the solvent is 95 gram. So how we found the molar mass of the cane sugar? So cane sugar formula is, actually it says sucrose. So sucrose formula is C12H22 and O11. So if you have to find the molar mass, we multiply 12 into 12 plus 22 into 1 plus 11 into 16. So after solving it, it is 346 gram per mole. So the same formula, same value, we substituted here. And we got the mass of solvent as 95 because total solution is 100. So here we know that total solution is our 100 and the mass of the cane sugar is 5. So based on that, mass of solvent is equal to 95 gram. So we can substitute this value, but this is in gram, it must be in kg. So we multiply by 1000. So further solving, molality is equal to 5 by 95 into 346 into 1000. So it's equal to molality. It will be 0.152 mole per kg. So now we found the molality. So we can substitute the molality here. So it is equal to 2.15 K Kelvin is equal to Kf into 0.152. So Kf is equal to 2.15 divided by 0.152. It's equal to 14.14 Kelvin kg per mole. Now we have the Kf value and we have to find the freezing point of the glucose. So what we do, again we use the same formula here, but now we already know the value of Kf. We can find the molality and then we can find the delta Tf. So for finding the delta Tf of glucose, we can write it for glucose. Kf we got it just now, 14.14 Kelvin kg per mole. T naught F 273.15 Kelvin, and we have to find Tf. So again we use the our freezing point formula, depression of freezing point, it's equal to Kf into m. Now we have to find the molality. Molality is equal to mole of glucose divided by mass of water in kg. So here mole of glucose is equal to given mass by molar mass. Given mass is 5 gram. Molar mass is 180 gram per mole. We know that glucose formula is C6H12O6. So we can find it molar mass 6 into 12 plus 12 into 1 plus 6 into 16. So it is 180 gram per mole. So now we found the mole, it can be further cancelled. So 1 by 36. It's equal to 0.028. So now we have the mole. We can substitute the values. Delta Ef is equal to 14.14 into 0.028. Mass of the water is 90 gram into 1000. So delta Tf is equal to 14.14 into 28 up 90. So it's equal to 4.37 Kelvin. So we got the delta Tf, and delta Tf is equal to T naught F minus Tf. So we have to find Tf. it's equal to T naught F minus delta TF. So we substitute the value. T naught F is equal to 273.15 minus 4.37 Kelvin. So it's equal to TF is equal to 268.78 Kelvin. So this is the answer of this question.